Okay, so now we're getting into rational numbers. Okay, so rational numbers, I'm not sure if you guys have heard that term before, but basically we're just looking at fractions. Okay, so we're going to get into some fractions, and the first note is just going to be on adding fractions. Okay, our second note today will be on subtracting fractions, and then we'll go into multiplication and division, which is actually a little bit easier than adding and subtracting fractions, and you'll see why as we go to it. So when we're looking at them, we'll have a number over another number. So the top number here is called our numerator. And our bottom number here is our denominator. You might want to write that down. Okay, so our job when we're adding is to find the lowest common denominator. So you've probably heard of that before, or LCD. And basically what you have to do with that is when you're adding fractions, you need to make sure that the bottom numbers or the denominators are the same. And if they're not, you either have to multiply one to equal the other, or you might have to multiply both to make sure that they match up. It's okay. So our job is to find equivalent rational numbers with the lowest common denominator. That's just exactly what I talked about. And then all you do is add the numerators and keep the same denominator. So our job is to find the same denominator, and then all we do is add those top numbers or the numerator. And then reduce to the lowest term. So if you're not familiar with what that means, is that if both numbers can be divided by something, we can reduce them. So if we have 2 over 4, we can actually divide both numbers by 2 to reduce it to 1 over 2. If you remember that from last year a little bit. But we're just reducing numbers, meaning if they have similar divisors, that we can do that, okay? So if we look at the first question, we have the same denominator, okay? So we have the same denominator, meaning that step 1 is done. And then we can jump all the way to step 3, which is add the numerator, and keep the denominator. So all we would do is, to keep things simple, is 1 plus negative 3 would then be negative 2 over 5. Okay, that would be our answer. Is that pencil working over there? Yeah, okay, cool. So for the next one here, next example, we have negative 5 over 9 plus negative 2 over 9. Same thing, we have the same denominators. So it would be negative 5 plus negative 2, giving us negative 7 over 9. In both of these examples, we cannot reduce because they can't be divided by anything the same. So negative 2 could be divided by 2, but 5 can't be divided by 2. Negative 7 is a number that can't be divided by anything but itself, and 9 can't be divided by that. So that's the case. You'll also realize this note that I've done it subconsciously, but you'll notice the negative signs are beside the numerator always, okay? So if the negative sign is in front of the rational number or in front of the denominator, we want to move that right away to in front of the numerator. So you see what I've done right here? Now, if we look at the next example, it's going to show us what we mean by that. So this right here is in front of the whole rational number, the whole fraction. We're going to move that beside the 3 or the numerator. So in this case, if we rewrite this, if we were to rewrite this, it would then be rewritten as negative 3 over 5. And then we could just do that 1 over 10, okay? Now, here's a tricky part where we need to find the common denominators. So 5 and 10 aren't the same denominators, but we know we can do something to 5 to turn it into 10. Yeah. Yeah, we multiply by 2. And whatever we do to the bottom, we must do to the top as well. So whatever we do to the denominator, we must do to the top. So in this case, we'd have negative 3 over 5. And like what was said is to get 10 out of 5, we got to multiply by 2. We also have to multiply the top by 2. Yep. Correct. You got it. Now, the other side, we have 1 over 10, but to get 10, we just multiply it by 1, right? So it's the same thing. If we don't have to do anything to that second number, it's just multiplying by 1, and you're going to notice we have the same thing. However, negative 3 times 2 would be negative 6, and 5 times 2 being 10. And then we know 1 times 1 is 1, and 10 times 1 being 10. So we have the exact same thing. So that step was kind of unnecessary, but it just goes to show you that sometimes we're going to have to multiply both numbers, okay? And you'll find that out in our next example. Now that we have the same denominators, we can just do our addition across. So negative 6 plus 1 would be negative 5 over 10. And the interesting part here too is there's another equal sign there, and you might think, well, why is that there? But it's because we need to reduce it. So when we reduce something, it means that there's a number that we can divide both the top and the bottom by. And in this case, it would be 5. So if I divided both the top by 5 and the bottom by 5, I can reduce this to negative 1, because negative 5 divided by 5 would be negative 1, and 10 divided by 5 being 2. So it's negative 1/2. If you think of this, if you want to peel it back a little bit, 5 out of 10 is 50%. That makes sense, right? If I have 1 out of 2, that's also 50%. So it's the exact same number. We just reduced it to its most simple form, okay, or most reduced form. That's all we've done there. Okay, so that would be your answer, negative 1 over 2. All right. The next one is where we're going to see a little bit of some change here, okay? So I just got rid of the blue line. So what did I say we have to do when we have that negative sign in front of the fraction there? What do we have to do? Yeah. Yeah, so move it to the denominator. And then how about the second one there? What do I got to do? Sorry, move it to the numerator. I apologize. What do I have to do with that, Nazir? Move it here, right? Is that where you're getting at? Oh. Yeah, so we always put that negative sign on the numerator or the top number, okay? It just makes things a little bit easier, and it just organizes it way better. And it's just, especially when we have the same denominator, all we're doing is adding or subtracting on the top. So it just keeps things a lot easier for us to understand, okay? So in this next thing, we don't have the same denominator. 9 and 6 aren't the same. So we got to think of a number that we can multiply both of those numbers by to equal something. Yep. So 3 is correct for one of them, because they can be two different numbers. I apologize, but we want to end up with the same denominator. So what are something that both of these numbers could multiply to? Any ideas? Maybe I'll show you. If I have negative 2 over 9, 9 times 2 is what? 18. And if I have 1 over 6, 6 times 3 is what? 18. So we need to find something that we can multiply these two to make the same denominator. So in this case, that LCD is equal to 18. So to get that, we had to multiply the 9 by 2 and the 6 by 3. So -2 times 4, or sorry, -2 times 2 is -4, and 9 times 2 is 18. And then -1 times 3 is -3, and 6 times 3 is 18. So does that make sense how we did that there, guys? Yeah. So basically, you're always trying to find a denominator. And to do that, you got to think of, okay, if I have these two numbers on the bottom, what could they multiply to that they have a similar multiple of? So in this case, we know 9 and 6. Well, if I multiplied 6 by 2, that only gives us 12. I can't multiply anything by 9 to get that. But I can, if I multiplied it by 3, I could go 18. And yeah, 9 times 2 would be 18. That's kind of how you have to work it through your head here. So then if we just did our adding across the top, what would we be left with? -7 over wicked. Okay. So that is that. You guys have the assigned work to do. Okay. So let's work away at that, and then we'll take a breather outside there. Okay.